In 2019, scientists announced they had discovered the oldest known cave paintings in Spain. They were created about 65,000 years ago by humans of the Aurignacian culture. The images include what appear to be handprints left by our ancestors. But there's something else too, something they didn't mention in the press release. In the background of one image, almost invisible, are two small dots. They look like nothing more than smudges at first glance. But according to the researchers, they are actually abstract representations of the sun and moon. If true, this would make them the oldest known example of figurative art in the world. It would also show that these ancient people had already started thinking symbolically long before they had developed language. But why did they feel the need to represent the sun and moon? What did it mean to them? Well, the answer probably lies in the climate they lived in. You see, during the last ice age, much of Europe was covered in thick sheets of ice, but not where these paintings were found. About 130,000 years ago, during the height of the last glacial maximum, the Iberian Peninsula was an island of warmth in a frozen sea. While the rest of Europe was buried in ice, the southern tip of Spain was a lush green tropical paradise. This is because the Gulf Stream, a warm ocean current, carried tropical water vapor from the Americas to Western Europe, creating a mild, wet climate that lasted all year round. And when the glaciers melted around 14,000 years ago, this climate, known as the Younger Dryas, persisted for another 1,000 years before the Ice Age finally came to an end. So for 128,000 years, people in this region lived under a warm climate with abundant rainfall. No wonder they felt inspired to paint pictures of the sun and moon. The climate they lived in probably looked much like what we see today in parts of Southeast Asia or the Amazon rainforest. In fact, if you travel to southern Spain today, you can still find small pockets of this tropical paradise in the Doñana National Park, a wetland full of meandering streams, leafy green trees, and colorful birds. It may seem hard to believe, but until very recently, this environment supported megafauna. That means giant animals similar to those we find in today's tropical rainforests. According to the fossil record, elephants with enormous curved tusks roamed the Iberian Peninsula until 3,500 years ago. Meanwhile, woolly mammoths survived until just 1,500 years ago. To put that in perspective, Julius Caesar was alive when these mammoths went extinct. And yet most of us have never heard of them. Hi, it's me and welcome to Paleologic. Today, we're going to examine how the Earth's ever-changing climate shaped prehistoric life. Every once in a while I get messages from viewers who think I should focus less on the science and more on the storytelling or vice versa. But with each passing episode, I try to do both. After all, understanding the science behind the story is what inspires me to tell the story in the first place. And so if you enjoy the storytelling but find yourself confused by some of the science, I encourage you to take the free brilliant course I've been taking myself. It's designed for beginners and covers topics such as supply and demand, exponential growth, and statistics. As someone who's always been intimidated by math, I love the interactive lessons and visuals. Brilliant uses because they help me learn complicated concepts easily. If you prefer to learn by doing rather than just watching, then I think you'll love it too. Alright, let's get to the tropical time travel. When the glaciers covering northern Spain melted around 14,000 years ago, they revealed a landscape transformed by the ice. The weight of the glaciers had actually depressed the land, so now that the weight was gone, the land began to rebound. This process called isostatic rebound will continue for another 10,000 years. But in the meantime, the rising land exposed a vast plain that became the heartland of prehistoric Europe. This is where the Aurignacian culture flourished, creating some of the earliest works of art in history. But this new landscape was a double-edged sword because, as the land rose out of the sea, it also moved away from the Gulf Stream. Over the next few thousand years, the climate gradually became drier and colder. Meanwhile, farther east, the climate was doing the opposite. Around 15,000 years ago, during the height of the last ice age, northern China was a frozen desert. But as the glaciers melted, a moist, temperate climate moved into the region. This led to the formation of the North China Plain, an area that would later become the cradle of Chinese civilization. So throughout history, dramatic changes in climate have repeatedly reshaped the face of our planet. During the last 500,000 years, the Earth has cycled between glacial and interglacial periods, meaning that the climate fluctuates between freezing and balmy every 100,000 years or so. These cycles are caused by slight changes in the Earth's orbit that affect how much solar energy reaches the poles. And although the overall trend over the past 2 million years has been toward colder temperatures, there have also been warmer periods within this overall cooling trend. One of the warmest was the Eemian interglacial, which peaked around 130,000 years ago. During this time, global temperatures were 2 to 3 degrees higher than today, while sea levels were up to 6 meters higher. The Eemian is considered a tropical period because the polar regions were completely ice-free. It was also a time of great environmental instability with rapid fluctuations in temperature and precipitation. In other words, the climate was chaotic. And just like today, the impacts of climate change were felt around the world. For example, in South Africa, the Eemian saw the extinction of several species of early humans, including Homo sapiens, Heidelbergensis, and Homo sapiens neanderthalensis. The only surviving species was Homo sapiens sapiens, modern humans. Now, most scientists agree that these extinctions were driven by a combination of factors, including competition with other humans and the emergence of new predators. But climate change probably played a role too, since the warming trend also coincided with a drying trend. According to one study, the shift from the cold and wet Middle Paleolithic to the warm and dry Eemian saw a significant decline in plant diversity across southern Africa, leading to habitat loss for many animals. For instance, the fossil record shows that the Eemian was a bad time to be a big herbivore in South Africa. This was also true in Europe, where the Eemian saw the extinction of the woolly rhinoceros, and the arrival of drier conditions paved the way for the steppe to expand northward. Meanwhile, the rising temperatures and increased precipitation triggered the expansion of the Amazon rainforest. In fact, the rainforest may have reached its modern extent during the Eemian. All this to say that the Eemian was a time of great upheaval and ecological restructuring. And just like today, the changes affected some species more than others. Nowhere was this more apparent than in North America, where the Eemian saw the rise of megafauna, including the Irish elk, North America's largest land mammal. Growing to 7 feet tall and weighing nearly 3 tons, this animal resembled a giant moose. But its massive size wasn't unique to the Eemian. In fact, scientists estimate that the average body weight of mammals has increased during each interglacial period for the last 2 million years. This trend is called the interglacial megafauna effect, and although scientists don't know exactly why this happens, they suspect that warmer temperatures allow animals to grow larger because bigger bodies conserve heat better. During the Eemian, this trend reached its peak with the evolution of North America's largest land mammal, the woolly mammoth. Weighing up to 12 tons, it looked like an African elephant with long, curved tusks and a high domed skull. Scientists think this trend toward gigantism may have ended when the glaciers returned and killed off most of the megafauna. Although it's important to remember that body size isn't everything. Take Smilodon, the saber-toothed cat, for example. It lived in South America during the last ice age and weighed a relatively small 400 pounds, yet it was an apex predator thanks to its giant saber-like teeth. As you can see, every major climate shift triggered a cascade of changes across the planet, affecting the types of plants and animals that thrived in different environments and even influencing the behavior of our early human ancestors. So understanding past climates helps us understand what life was like for the animals and people who lived in those times. It also helps us predict how life on Earth will change in the future, because whether we like it or not, we are about to enter another warm phase. In fact, the last 3 warm phases all happened during an overall cooling trend. This suggests that we may be living through the warmest period in a much longer cycle that repeats every 100,000 years or so. If true, then the next glacial maximum won't arrive for another 75,000 years. But until then, we can expect the climate to continue getting warmer. And although warmer temperatures may be good for some species, others will surely suffer. So let us just hope our descendants don't end up painting pictures of us the same way we look at the cave paintings of our ancestors. If you liked this episode, please subscribe and leave a comment below with your ideas for future episodes. Thanks for coming along on this journey through time.